see more. We'll see during our course what are these other database objects, right? But when we talk about application tuning, we say it includes tuning of your SQL statements, your PL SQL code, your table storage and design, and your other database objects. What about database tuning? It includes tuning of the memory, it includes tuning of the disk I/O, it includes tuning of the operating system, and eliminating database contention. I hope you understand that when we have multiple users accessing the same set of data, we can have database contention. So how do we try and eliminate that? So that's what is database tuning. Now the question also comes is, who does this tuning? Typically, let me tell you, designers and developers do the application tuning, and administrators do the database tuning. But having said that, let me also say this, that there is no bifurcation, there is no clear rule which says this is what the designer and developer can do and this is what the administrator has to do. There's a very thin line. There are a lot of times a developer's job is done by the administrators also. So yes, all of these people can tune the application basically. Now, when do we tune? We actually, to tell you the truth, tuning is an ongoing process. As you can see, we say it is tuned at every stage of the application, at the design phase, development phase, and the production phase. So we have something called as proactive tuning and reactive tuning. Proactive tuning before the database goes into production in the design phase basically. And of course, if you are proactively tuning your application, your cost will definitely be low. But if you are doing reactive tuning, your cost can go very high. Right? Now, what is the performance dilemma that we face most of the times? What are the statements that we come across most of the times, or what comes to our mind is, say I've got indexes on my filter columns, but still my query is running very slow. Why? Or my tables are not very large, but still my query takes a very long time. Why? What should I do here? Now, which part of my query processing is the bottleneck? Is the creation of the execution plan the bottleneck, or is it the execution of the execution plan the bottleneck? So which part of the query processing is the bottleneck? And then, of course, very, very important, which tool should be used to find this bottleneck? Now, all these questions will be answered in this particular course. You will be able to answer it on your own once you go through this course. So let me tell you what we are going to do in this, what we are going to cover in this course. We'll of course first talk about, we'll take an overview of tuning, we'll look at what is tuning process, and then we'll talk about what are the tips for avoiding problematic queries, what are the common things that we keep in mind while writing our queries, then the syntax considerations, programming standards, and then analyzing a problem-based SQL statement and to understand the nature of the problem. Now, once we've done this, what do you think should be done next? So what we are going to do next is look at the tools that help us in evaluating our SQL statement. I will quickly show you some examples using these tools so you can get an idea about how they work. Oracle gives us the tools like explain plan, auto trace, SQL trace for examining the execution of a SQL statement and understanding where exactly the problem lies. So let me quickly show you. First, let me quickly show you the explain plan tool. Now, explain plan is a tool which gives us the execution plan of a statement. How exactly is my statement getting executed? So explain plan is used quite a lot because it's a tool which does not go through the execution phase. It only gives us the execution plan. Okay, I'm using a table called customers. Now, I have, if I show you the number of rows in this table, okay, we have around 55,500 rows in the table. Now, I've got a column called customer marital status. Okay, so let me quickly show you that. I've got a column called customer marital status here, right? Now here, most of the times my query uses this particular column. So what I have thought about is to create an index on this column, right? So I'm going to use an index on this. I'm going to create an index on this column. So create an index called customer marital status index on the table customers, right, on the customer marital status column. Now, as we have an index present on this table, we've created this index on the table, my thought that comes to my mind is, okay, now if I have queries on this table, this index can be used, right? A lot of times people say, I have this count queries executed a lot of times. Will my count queries use the index? Can it use the index? Yes, it can. Why not? Because index contains your data from the table. So instead of going and scanning the whole table, my count queries, I'm expecting that it should use the index. So what do? I say, okay, let me do an explain plan for this. I say explain plan for select the count query. Now what exactly happens here? The question that arises here is, does it use my index? So how do we check? Explain plan utility gave us the execution plan, but it does not give us here. It stores it in something called as a plan table. Now I am going to select from that plan table to see what is the execution plan created for this particular query. DBMS explain plan dot display. This is again all given by Oracle itself. You need not do anything. You can just have a look at this. What does it show you? It shows you an execution plan saying it is accessing the full table customers. Now, my point here is I've got a customer marital status index, but why is it using a full table? Why not scanning from the index and getting this information like count, which is a very simple information? Can you imagine it going through the whole table? Can you imagine the cost? Yes, the cost is pretty high. Now, I want you to notice, I want you to understand this index that we have created is a bitmap index. No, sorry, a B-tree index, I'm sorry. Now, B-tree indexes do not store the null values. The reason why your count query has to go to the table and do a full table scan. So, let me go ahead and drop this index and create a bitmap index. A bitmap index stores the null value as well. Right? So instead of just saying create index, I actually say create a bitmap index. Now I want you to notice the difference. If I say explain plan for select count, remember every time you want to see the difference, you need to execute your explain plan again. Do we notice something? The cost has come down from 422 to 5. And what is it actually using? It's using the bitmap index full scan instead of table full scan. Now this is something which you can see with the help of your tool called Explain Plan. So it's a very, very helpful tool in checking the execution plans of our statements, and it again helps us in answering one of the questions saying, I've got indexes but my index is not getting used, or I've got indexes, still my query is slow. So a lot of times we are not even aware whether my index is getting used or not. So only when you see the execution plan of your statements, you can actually find out whether the index is getting used or not. Right. Now we have another tool called auto trace, which is as simple as just setting your auto trace on. It is as simple as this. Saying set auto trace on. As simple as this. It's a simple setting. Now, what exactly happens when you say set auto trace on? What it does is it starts giving you the execution plan of any statement that you execute after this. Remember, this is something that we use only in our development sites, but we do not use it at the production databases. Development databases, yes, I can afford to maybe add some load. Production environment, no. So auto trace, I'll give you a simple example here, saying I'll give you the same query, and I want you to notice that it gives us the execution plan from the explain plan table automatically. So yeah, I don't have to use the explain plan utility. So a lot of times people ask me this, why do I need the explain plan utility? It looks very tedious. Why not just set auto trace on? It's so simple, but you need to understand the difference between the two. Explain plan utility is used in a production environment because it does not really add on to the overhead, as it does not execute the statement. It only creates the execution plan and gives it to you, whereas auto trace executes the statement also, and then after executing the statement gives you the execution plan. So this will have an overhead effect, right? Then what we are going to have a look at is another tool called SQL trace. SQL trace is a utility which allows us to have a full set of trace. Explain plan and auto trace works one statement at a time. That's a full section trace. Let us say I don't know which query is created. SQL is utility. Then you also have at our interpret our SQL trace file, which are the tools which will basically help us in evaluating our SQL statements. So we are going to get them in details. And then we will have a look at the optimizer statistics, saying what exactly is an optimizer, what does it do, what are the different types of optimizers that we have. We have called as a cost-based optimizer, and then we'll see how does these statistics gathered for this optimizer. Then we will have a look at how the process something is done a lot of times, or by clauses, or maybe setting your tables of how it processes stuff. Then, very, very important something to see here is indexes. Indexes, as we know, is an object which most of the times used for performance, which is most of the times used for performance gain. Okay, is my voice breaking? Or is it clear for you all? Is it clear now? Right. Continuing with this, we will have a look at indexes where we will talk about, right, what I'll do is maybe go back and tell you what I was talking about. I was talking about these are the tools that will give us, basically it will help us in evaluating our SQL statements. Then we will understand what are the different types of optimizers and how this creates the execution plan. So the optimizer is a very important pattern in execution, as it is the one which is responsible for creating the execution plan. Then we will have a look at the sorts as for your joint indexes. I really don't know why the voice is breaking. I am we will talk about something called as indexes, where we will have a look at different types of indexes called B-tree indexes and bitmap indexes. We will also have a look at what are the different access paths that are used with indexes, what are the different access scans, and what are the conditions that stop indexes being used. So let me quickly show you an example where we will have a look at when the index is used or when the index is not used. Is my voice clear now? Is it better now? Okay, right. So let me quickly show you something on indexes here, which is again very, very important part of our index, of our tuning, sorry, I'm so sorry. I'm going to work on a table called employees. And these are tables which give us a lot of examples. So I'm going to use this, where we have a column called department ID and job ID. Now I've got an index created on this. I say most of the times I have my columns department ID and job ID used together. So I have a department job index on my table employees, which has department ID and job ID. Right? What do you see here? You see a composite index, basically index containing multiple columns. So how this index will be created is department ID sorted first, and within each department job ID sorted. Now I'm going to use my explain plan utility and say explain plan for I can use my set auto trace also instead of using explain plan. That will be easier right now. As I said, auto trace only, because I don't want to see the result set. Explain. Only give me the execution plan. I want you to notice a few things here. As I select from employees, where department ID is equal to let's say 60 and job ID is equal to mistake here. This is have a look at this. It gives me an execution plan where the index is getting used. And which is the index getting used? The one which we just created, right? Because we have the department ID and job ID both in this index. So what if my statement is, instead of saying and, I have a or operator. Question is, will the index get used? Please notice, index not used for an OR operator. The moment you say OR, it goes for a full table scan. Or I have a condition saying where department ID is not equal to 60. Again, what do you notice? Index does not get used. It's a full table scan. Or I have a condition where I say where upper of job ID, basically showing you that we have a function which is used here in our query. So when you use a function on the condition column, the index is again ignored. So what am I actually trying to tell you? That when we talk about indexes, a very, very common question that comes to our mind is, see, I've got my index on these columns. First question that comes to my mind is the index getting used? How do I see? I see it only in the execution plan. Now, when my index gets ignored, according to me, I've got an index on department ID, job ID. When I write a OR operator condition, it should get used, but it does not. So what are we saying? OR operator ignores the index. When I use a not equal to, my index gets ignored. When I use a function on the index column, my index gets ignored. Now this is what we will discuss in indexes, saying what are the conditions that stop the indexes being used. Right? Very, very important. Then we'll talk about advanced indexes, where we'll look at bitmap indexes, we'll look at index organized tables, function-based indexes. And remember, these types of indexes are quite useful. In what scenarios? We will have a look at it. Then most of the times what we do in our queries is a join. So we will understand what are the different access paths that Oracle uses for joining the tables. Joins like nested loops join, merge join. Remember, these are the joins that Oracle can perform. So what are these joins? When are they used? Which one should be used when? So we will have a look at this in details. And then Oracle gives us something called as a tuning advisor. So we will have a look at this DBMS SQL tune package and how do we use this. Sorry, you've given me a question, Shrikant, I can see, but just give me another 2 minutes to quickly tell you what all will be covered in this course, and then maybe I'll answer your question, okay? Just give me 2 more minutes. We will have a look at the, we'll have a look at the SQL Tuning Advisor, which helps us in tuning our statements. We'll have a look at SQL Plan Management Tool. Then we'll have a look at some other objects that help us in performance gain, something like sequences or our inline views, right? And finally, we will have a look at how do we use hints to influence the creation of, the SQL plan management includes the baseline creation. Shrikant, you're right. We will talk about all that here in SQL plan management, right? And then, of course, we will have a look at the hints. How do we use the hints to influence the creation of execution plan? And we'll look at few small topics that again help us in performance gain. So, any questions that you have now, please ask. I have given you an overview of what we are going to cover in this course. I've also shown you the tools that we will be using. I've given you information about indexes. This was just to give you a very, very brief idea about what we are going to cover in this course. So now, if you have any questions, please, you can ask. Shrikant, I'm not able to hear you. Have you muted yourself?